Hi everyone, welcome back to my channel. My name is Lloyd. In today's video, I'm going to talk about S3 files, its use case, and its security model. If you haven't subscribed to the channel, you kindly subscribe to the channel. For almost 2 decades, developers had to make a painful choice to use Amazon S3 for its legendary durability, scale, and integration, or use a file system so that their apps can read and write files like normal software does. Well, this has changed. On April 7, 2026, AWS has launched Amazon S3 file, and it changes everything about how we store objects nowadays. So S3 is now the first and only cloud object store that gives you fully featured high performance file system access to your data. To understand why this is a big deal, we need to talk about the fundamental difference between object storage and then a file system. Now, object storage like S3 treats your data as a self-contained object. Each object has its own metadata, data, and a unique key. Think of it like a warehouse where every package is sealed, labeled, and then stored in a flat namespace. You can retrieve any package instantly, but you cannot open that package and edit just one item. To change anything, you have to replace the entire object. Before today, these two worlds didn't talk to each other natively. If you had data in S3 and a machine learning team member needs to train a model on it, they had to copy the data out of S3 into EFS or any local disk. Now, what happens is that you're going to pay for duplicate data storage, also manage multiple job syncs, and worry mostly about data drift. Now, this approach is expensive and operationally it is very complex. S3 files is here to kind of like eliminate that problem. Now, you have one bucket accessible as both an object store and at the same time a file system. S3 file is actually built directly on top of Amazon S3. It makes your S3 bucket accessible as a native file system on any AWS compute resource like EC2 instance, ECS containers, EKS pods, and Lambda functions. For ECS and EKS, it is even cleaner, and here is why. You define the file system as a volume in your task definition or pod specs, same as you would with EFS, and containers get automatic access based on their IAM task rule. So in this instance, your code configuration needs zero additional configuration on the side of the application. Under the hood, it uses a network file system, which is the industry standard for shared file access. This means your application doesn't need any code changes. If the applications can mount an NFS file system, they can now mount your S3 buckets. The most important question is, when should you actually use S3 files? Now, a typical example is machine learning model training. This is the one that saves data science teams a lot when it comes to their workflow. Previously, training a large model on S3 data means that you have to copy terabyte of data to a local SSD or EFS first. With S3 files, this has changed. Your training scripts like PyTorch, TensorFlow are all mounted into the S3 bucket and read the data or the training data directly. The latency for this is approximately, let's say, 1 ms for data operations. And for large sequential data reads, which is what machine learning training does, the throughput is optimized automatically. The second use case is agentic AI systems. Agentic AI systems need to read and write files, but object storage doesn't support that behavior out of the box. With S3 files, your agent can now interact with storage using familiar file operations like in any Python script while still benefiting from the durability and shared access of Amazon S3. Unified data lake. If your data sits in Amazon S3, your analytics team can now query it with Amazon Antenna, AWS Glue, and Amazon Redshift Spectrum using the S3 APIs. At the same time, your data engineering team can also run Python and Spark jobs that will require file style access. Both workflows operate on the same bucket. No data movement is needed in this instance. So you have one lake with multiple access patterns. Now that we understand the use case, let's go to the security. Now, let me cover the security model if you are in a regulated industry like, let's say, finance, healthcare, and then the government sector. Access control is handled entirely by AWS. You use the same identity and resource policy you already have on your S3 buckets. Identity-based policies on your EC2 instance role or ECS tax role control what operations are allowed. Resource-based bucket policies added a second layer of defense in terms of security. There's no separate permission system. AWS S3 files integrate with your existing IAM infrastructure. So the first security aspect is encryption in transit. All data between your compute and the mount target is encrypted using TLS 1.3. This is actually enforced by Amazon and it cannot be disabled. The third one is encryption at rest. Data is encrypted at rest by default using SSE S3. This is S3 managed keys. If your compliance requirement demand customer managed keys, you can then enable SSE key management service and point it at your AWS key management service customer master key. And the last one I will talk about is network isolation. And so because your mount targets live inside your VPC, your data never traverses the public internet. The traffic stays on AWS internal network fabric. You can add VPC endpoint policies and additional control and use security groups to enforce least privilege network access. Thank you for watching, and this brings us to the end of this video, this S3 review. What is your key takeaway? Let me know in the comment section, and thanks for watching.